Good day, everyone. Today, we're diving into one of the most powerful ideas in calculus, the equation of the tangent line. This concept connects geometry, algebra, and limits, and it's gateway to understanding derivatives. And to make it come alive, we'll be using GeoGebra, a dynamic math visualization tool. Ready to explore? Let's go! Let's start with a specific question. What is a tangent line? Imagine a curve. Say the graph of y is equals to x squared. Pick a point P on the curve. Now choose another point Q nearby. The line connecting P and Q is called a secant line. But what happens to Q when it gets closer and closer to P? As Q approaches P, the secant line becomes the tangent line. It is the line that just touches the curve at P and has the same direction as the curve at that point. But how do we find the slope of this tangent line? We have the concept of limits. The slope m is the limit of the slope of the secant line as x approaches x sub 0. In symbol, m is equals to limit as x approaches x sub 0, f of x minus f of x sub 0, all over x minus x sub 0. This is the foundation of the derivative. For example, find the slope of the tangent line to the function f of x is equals to x squared at x equals 2. To solve this, we will use the limit definition of the derivative. First, we substitute the given function f of x is equals to x squared into the formula. We also find the value of the function at x equals 2. f of 2 is equals to 2 squared. That gives us 4. So the point on the curve at point P is at 2 and 4. Next, we substitute everything into the formula. Limit as x approaches 2, x squared minus 4 all over x minus 2. At this point, we cannot directly substitute x equals 2 because the denominator becomes 2 minus 2 is equals to 0. This would make the expression indeterminate. What is indeterminate? This means that expression does not have a single, defined numerical value. When evaluating a limit, that resolves the form 0 over 0. So what should we do if it is indeterminate? Right! We simplify the expression first. Let's factor the numerator. X squared minus 4 is equals to the quantity of x minus 2 multiplied by the quantity of x plus 2. Now, substitute this back into the limit. Limit as x approaches 2 is the quantity of x minus 2 multiplied by the quantity of x plus 2 all over x minus 2. We can now cancel x minus 2 from the numerator and the denominator. That gives us limit as x approaches 2 is the quantity of x plus 2. Now, it is safe to substitute x equals 2. 2 plus 2 is equals to 4. Therefore, the slope of the tangent line at the point P to 4 is equals to 4. Once we have the slope m and the point P, x sub 0 and y sub 0, we can write the equation of the tangent line using the point slope form. Y minus y sub 0 is equals to m quantity of x minus x sub 0. What is the purpose of using the point slope form? To use point slope form, you use the formula y minus y sub 0 is equals to m quantity of x minus x sub 0, where x sub 0 and y sub 0 is a known point on the line, and m is the slope, allowing you to write the equation of the line when you have one point and the slope, or to find other points by plugging in values. You substitute your known slope and the coordinates of the point into the formula, and can then simplify it to the slope-intercept from y is equals to mx plus p if needed. Let's plug in our values. M is equals to 4. P is equals to 2 and 4. We get y minus 4 is equals to 4 multiplied by the quantity of x minus 2. And now, we simplify. Y is equals to 4x minus 4. That is the equation of the tangent line. Let's try another example together. Open GeoGebra and plot the function f of x is equals to the square root of x. Choose the point x is equals to 4. What is the slope? And now, we compute. M is equals to the limit as x approaches 4 is square root of x minus 2 all over x minus 4. Using GeoGebra tool, we find that m is equals to 1 over 4. The point is 4 and 2. So the equation is y minus 2 is equals to 1 over 4 multiplied by the quantity of x minus 4. Plot it and see how it touches the curve. The foundation of the equation of the tangent line begins with the slope of a line, defined as m is equals to y minus y sub 0 all over x minus x sub 0, which measures the rate of change between two distinct points. Using given points, the slope of a line can be compounded and verified graphically by plotting the points and applying the slope tool in GeoGebra. Tangent lines are more than just lines. They're the beginning of calculus. The key to understanding change: keep exploring, keep asking, and keep using tools like GeoGebra to make math come alive. Thanks for watching. I hope you learned something today and try your own examples on GeoGebra.